Hello everyone, welcome back to school again. I hope you all had a great break. Today's problems that we'll be working on is just a review of 8.1 and 8.2. And we'll go over about 2 problems only in this lesson, so it'll be pretty short, and your homework is also pretty short. It's only 1, 2, 6, and 7 from page 470. So yeah, go ahead, turn to page 470, and we'll start working on the problems for today. Let's see here. So the first question asks you to graph g of x, which is equal to negative 4x squared. And it asks you to compare to the graph of f of x equal to x squared. So before we even begin, let's start by creating a table. That'll be our first step. Make a table. So x on the left side, y on the right side. So if we plug in 0 for x, what would happen? We would have negative 4, 0 to the power of 2. 0 to the power of 2 is 0 times negative 4, which is equal to 0. So that means if we plugged in 0 for x, we would get 0 for y. Let me put this over here. Okay, so we have that done. And this will also be our vertex, 0, 0. So that means it's all, our axis of symmetry is going to be, let me write this over here, is going to be x is equal to 0. So that means if we plug in another number for x, it'll just reflect onto the other side. So let's plug in 1. If we plug in 1, 1 to the power of 2 is 1. And then 1 times negative 4 is negative 4. And we also know that since our vertex is 0, 0, and our axis of symmetry is x equals 0, this 1 will have to reflect over, and the y value will still stay the same. So all we have to do is copy the y value and just change the symbol in front of the 1. So 1 becomes negative 1. Okay, so now we need to graph this. Okay. Let's go ahead and try this on Desmos. It'll be a little bit easier. Okay, so first off, we'll start by just graphing it on our own. So 0, 0 would be right here. And then, actually, yeah, let's just do it here. It might be easier. Let me erase this real quick. Okay. Let's do this. Draw a graph. Alright, so 0, 0 would be right here. Oh, let me make that a little bit bigger. 0, 0 would be right there. Let's draw this real quick. 3, 4. So 0, 0 would be right here. 1, negative 4. Well, for 1, negative 4, we'd go 1 to the right and then down 4. 1, 2, 3, 4. So that'd be approximately over here. And since we know that our axis of symmetry is right here, it will have to reflect right over 2, as it shows right here. Negative 1, negative 4. So how many ever spaces this is 1 space to the right. We'll go 1 space to the left right here. Let me use a different color. So it'll look something like this. And how can we check if our graph is pointing the right direction? Well, if you look back to our original problem, it says g of x is equal to negative 4x squared. This negative here will make the graph flip upside down. If it was positive 4x squared, then it would have looked something like this. But since it's negative 4x squared, it flipped the other way. Alright, so let's draw what x squared would look like. X squared would look something like this. Let's see. Right here, those 2 points, because if we plugged in 1 for x, there would be 1 to the power of 2, which is just 1. And then if we plug in 2, then it will go up to 4. 1, 2, 3, 4. So this is what the graph of x squared would look like. Okay, so let me show you on Desmos real quick what it'll look like. A graph that's a little bit neater. So let's start off with x actually. Y equals x to the power of 2. And we can add another one right here. G of x is equal to negative 4x squared. So that's what it looked like. Notice that the graph on the bottom is skinnier, it's upside down, has different y values and x values this time, and is not a direct reflection. Okay. And if we want to describe this, this is how you would describe it. So you'd say that the graphs have the same vertex, 0, 0, right? They both cross at 0, 0, the vertex, and the same axis of symmetry, x equals 0. But the graph of G opens down and is narrower than the graph of F. So the graph of G is a vertical stretch by a factor of 4 and a reflection in the x-axis of the graph of F. Okay, let's try the next one. 8.2. So graph G of x is equal to 2x squared plus 3. So once again, start off by making a table. X on the left, y on the right again. And let's begin by plugging in a couple of points. So our favorite one, plugging in 0 for x. So if we plug in 0, we have 2 to the power of 0. Let's put this here. To the power of 2 plus 3, right? So 0 to the power of 2 is 0, plus 3. 2 times 0 is 0, plus 3. So we have y is equal to 3. So we're going to plug that in back here. And now we need to plug in a few more points. Let's try plugging in 1 this time. Go ahead and try it on your own. Okay. So 1 squared is 1. 2 times 1 is 2, plus 3 is equal to 5. And since we know that our vertex here is 0, 3, we know that 1, 5 is going to have to reflect over that axis of symmetry. So if it reflects over, it'll be negative 1, 5. Okay, so let's go ahead and start our graph. Alright, so this is our vertex. Let me write that down here. And let's make our graph. Let's make it a little bit straighter. See if I can get a shape here. There we go. It's a little lopsided. All right. So now, let's see here. 4. Okay, it can't seem to let me draw right here. Okay. Oh. Okay. Let me erase that. Okay. Let me drop a couple over here. Okay, so we have 0, 0, 3. So 0 would be right here. So we're not moving to the right or left since our x is 0. And we're moving up 3. 1, 2, 3, because we have positive 3. And now we have 1, comma, 5. So we're moving 1 to the right and up 5. 1, 2, 3, 4, 5. So that would be right over here. And we have negative 1, comma, 5. So it's just going to reflect across this axis of symmetry right over here. So since this is 1 to the right, we're going to make 1 to the left. All right, so that'll be enough. But if you have more space, I don't have too much space on here, we can calculate a few more points. If we plug in 2, we'd have 2 to the power of 2, which is 4, times 2, which is 8, plus 3, which is 11. And remember, this gets reflected too. So we have negative 2, comma, 11. Okay, let's connect the dots now. The graph would be up there. And so now describe how it would compare to a graph of f of x equals x squared. So let's go back to Desmos again and try graphing on a neater graph. So we have y is equal to x to the power of 2. And our second one is going to be g of x is equal to 2x squared plus 3. So this is the graph that we were just creating right now. Let me show you again, this one right here.